Hi everyone, welcome to Code and Chill. Last episode, we were looking at reverse linked list problem. Just to give a quick recap, we saw what is a linked list. We refreshed our memory, helped or got help from ChatGPT, and then while using English to solve this problem, we saw that recursion can be used here, and then we asked ChatGPT to provide us the recursive approach for this. And after that, since we had done a lot, we took a break because, as usual, the motivation or the purpose of this series is not to finish a problem, not to find the final solution, but to see our thought process, how it unravels, what are the different different concepts that we come across, and just find different solutions, keep our mind active, and have fun on the way. So the approach one that we had copy pasted from the ChatGPT, how to read this recursive method, I broke it down into three components, which is a stopping condition called as the base case, and then the condition that we need to keep moving forward here, and then what is the logic that we need to implement backwards. Now, just to make things quick, I already noted down a few things. So what I'm thinking today is, with linked lists, it is very easy for us to get into some complex problems, and we just go into a loop and we don't know how to debug. So I thought, why not use this opportunity to write a solution which is not actually correct. Okay. And this is a solution which is not actually correct right now. So, and then we will walk through the code and see what exactly went wrong. And let us see how to debug and try to come out of the wrong solution that is present here. So first of all, let me go back to the approach that has been written, right, in English. So let's see if that is correct. First of all, so initially we have a linked list. The head is given. What do? We go to the end of the linked list. Why? Because we want to reverse it, so we need to get this first. So we go to the end of the linked list. If you consider this as the current node, which is this one, we should also have the previous node. Okay. How, we will see later. But for now, okay, we need to have access to this one. And then we need to create a new linked list node, which has the value of the current node. So we need to create a new one, which has the value of 5. And but it should refer to 4 instead of to null. So it has to refer to 4. How do we do that? We need to have access to this node for that, right? So that's why we are having this previous node. So basically, the new node.next has to be previous. And once we do that, what do? Then we just assume need to have access to 3 as well as the new node, which is 5, right? So I think I missed that part here. Now assume that we have access to which one? The new current node equal to the previous node. which is this previous node. Okay, so that is the new current node and its previous node. So we have access to 4 and 3. And now we'll create a new node. Make this, I think this wording is not clear. So create a new node which has the value of the current node. Add the reference of the previous node to this new node. And then the new step here is now reference. What do we need to do? So this new node has to be referenced from the new node which was created here. Reference the new node to the previous new node. And we go on continuing that process till we are reached 1. So first thing is I have a code which looks like this. Now let's assume you are working with a team and somebody has written this code and gone on a holiday and you are asked to correct it. So this is what you do. First you see if, in English, or maybe you write pseudocode and you know what needs to be done, right? This part is very helpful. Then when you're seeing the code, you reference against what is already there. What is the correct logic? So this will be very helpful. Even before you go into actual debugging or whatever, just reading the code this way will be very helpful. So let's see how that works. So in recursion, one more thing is there is a stopping condition, a condition where you keep on going forward and somewhere you will stop and then you go backwards and you do some logic. So what did this person write? Let's see. Some imaginary person wrote this. Okay. So traverse to the end of the linked list. Get reverse linked list. Okay. The naming is good. We pass in the head, which will be a input parameter. Then we go to the end. So we do that one step at a time by going to node.next. When you at some point you'll know you reach the end, right? That is, if node.next equal to null, that means the tail node is reached where the next value will be null. What do you do? Traverse to the end, and then what you're sending back will become the current node. So what you're returning from this will become the current node. Okay. So far, so good. Okay. Also have the previous node. So the one that has been sent will become the previous node because node.next was the current. The result of this was the current node. Something does look fishy here because if you are returned the same node back without any processing, something could go wrong. So just add a red flag here, right? This is still intuition. There is no certainty yet. Okay. Now also have the previous node. Okay, we have that. Now create a new linked list node. Awesome. Let's create a new node. Okay, that looks good, which has the value of the current node. Done. And a reference from the previous node. Reference of the previous node, I'm sorry. So basically, this has to be previous node, not previous node. So basically, if somebody is sending you 5 back from here, current node will be 5. Previous node will be this one, right? When you're creating a new node, 5 should point to 4. 5 should not point to what 4 is pointing to here, which will be back to itself, maybe. Well, not to itself, but still. You don't want this 5 to point here. So that is wrong. We corrected one mistake. That's great. Awesome. So we did create a new node. That is Done. Oh, once that is done, we are returning the new node, but here we are returning the old node. That does not look right. But let's just continue and see what will happen if this disaster continues. So new node is sent back. Okay. So what was the new node? This was the new node. It is sent back. To whom? It is sent back to the one who is calling this. If it is confusing, I will just write it down. Okay. I think that will make it simpler to understand. I have written here for 1 and 2. But I think that's too simple. So I will go ahead and write for the other one. First of all, let me write recursion. So recursion starts with node 1. When I say node 1, it will have value 1, reference to node 2. Okay, just assume that it's too much to write. That's why. So let's go. So node 1 will call the next one, which is node 2. Now this one will call node 3. That one will call node 4. So if you have watched the movie Inception, that is what is happening. So node 5 is reached. This is where what? So when node 5 is reached, okay, this will happen. Node.next is null. So you're going to return 5. So this one was called from this method. Okay, so let me just execute that method. So I will just copy this so that it's very easy to see. Okay, so what happened? This one said, okay, I have reached node.next equal to null, I'll return 5. So that was returned to this one. So this was the call, right? This got completed and it returned node 5 itself, returned node 5. So this returned node 5. This condition was not relevant for node 4, so I will remove it. Now current node is node 5, previous node is node 4, new node will be current node value, which is 5, and previous node, which will be node 4 reference. So the new node is now referring to this one. Is that fine? Not sure, let's see. So this new node, I will call it, since it has a value 5, I will call it new node 5, okay? I will call it new node 5. Now this is going to be returned from here. Who called this? Who will get this? This one. So node 3 will have current node as what? New node 5. Previous node will be what? This one. What is the new node? It will be the current node dot value. What is the current node dot value? It will be 5 again. That looks like nonsense. And then the previous node will be node 3. And then 5a I will call it, because this is still, has a different reference, right? This one had, I think I have to write it down because the reference has changed. Okay. This is equal to this. Then this new node 5a has a value of 5 and node 3 reference. So that was written from here. Node, new node 5a. So this is how we can go on debugging. So let's quickly get these values and see what is the final result. Okay. So node 2 at this point, node 2, this is a manual debugger now. Okay. Whatever is happening. So the current node would have been this one. Previous node was node 2. New node, let's call it the value of the current node, which is still 5. Wow, something is seriously wrong. Previous node is node 2. What is this new node? 5a or 5b, we'll call it now. Okay. 5b. And that is being returned, blah, blah, blah. It will have the reference of 2. So the final one, it will be by b, node 1, node 1. Let's call it 5c. This is becoming crazy. Oh, we are sending all values as 5 only. So this one, basically now we have this. So what happens? We are creating a new node called 5, which has reference to node 1. And then, so if I copy paste this and in Excalibur, what happens? Let's see. Okay, let me draw this. So please excuse my drawing. I'm trying to be a bit fast here. So the new node 5c we have. So initially we had 1, we had 2, we had 3, we had 4, and then 5. The new 5c node, it has a value equal to 5 and it is pointing to 1. Okay. This is what we are returning finally. What happens after that? Though we created all these different things and they were wrong, of course, but this is what we have finally. We have a node called 5 and it points to 1 and then it gets 4, 5. That's all we have. We have a completely wrong answer, but we wanted something the opposite way. Where exactly did it go wrong? Let's try to see. So let's go back. We went through the code. We saw this is wrong. How do we correct it now? One good thing with ChatGPT or standard problems is that we can just do a search and get the answer. So apparently what ChatGPT provided here, right? Let me go through that. So this one is apparently right. But what I'm interested to know is, if going through the wrong code, can we get the right code? This is usually the scenario in real life. So let's go back to what we have written. We need to attach at this point the new node to the previous new node. We saw here that is not happening. The older nodes were getting reference to the new node. So that is one thing that has to change. Where did that start? Where did the first old node started getting reference? That was here. This was the starting point where things went wrong. So instead of sending the old node, we should send a new node. That is one thing to note. Why? Because this step, let me again quote it. To make this happen, we first need a new node. And we are sending in the old node. That's not going to work. That is the first part. But is that the only change? We will see. So let's first correct this part, which is one thing at a time. So new linked list node we are going to create. What should the value be? So we reach the end. We need to send the same value, right? So we need to send the same value. We don't know the reference yet. At this point, we don't know the reference. So we will just send the value and we will assume whoever we send the value to, they will figure out the rest. Okay. So we first created a new node. That is the first good thing we did. So what did we change in this logic? Let me again copy this. I will copy it to here. And so instead of doing the returned node 5, when we reach node 5, what happens? Node.next becomes null, and we are going to send a new linked list. This is not applicable. A new linked list of value 5. So return, I will call it I'll copy paste it here. So we are going to old execution, updated execution. So we have not done the rest of the things, right? So we have not returned anything. So I will just paste this. So the only thing we changed right now is that in the base condition, we are returning the new node 5. It has a value currently, and we have not sent any reference. So that is what we are doing. So one thing is corrected. So the next part was, so we traverse to the end, nothing wrong there. That will be the current node. So the old node has to be the current node, right? The current node is not the new node that is returned, but the old node. So what we will do is, this has to be called something else. Basically, that has to be the previous new node. And I'm sorry, I wrote it in the wrong line. I'm sorry. This is the previous new node. Okay. Where am I? Previous new node. Okay. The current node is actually the next node, or in the old linked list, not the new linked list. So the node.next is the current node. The previous node is like 4. And then the new node, so this is the backward logic. So the new node should be the current node's value, okay, and references the previous new node. So how did I understand these things? I will go back to the English, okay, and show. That's where I think I should copy everything. Come here, I'll paste it here. So now it's clear. See, traverse to the end. We reach the end. Now the last node will be the current node. So the last node was sent from here. So that is the current node. The previous node is also something we have access to. The new linked list has the value of the current node. I'm sorry, I'm in this step basically. The new node has the value of the current node, and it references the previous new node. Okay. If I have made mistakes, please feel free to add in the comment section, but we will debug this further and make sure that we got it right. Okay. So the new node, then we send this new node back. Now, does this solve the problem, or did we get something wrong? Let's see. So far so good. This was wrong, so I'll just remove this, okay? And now I will copy this. Okay. The stopping condition was taken care of here, so I will remove that. We don't need to look into it now. Now we are inside this one. So node 4 had called node 5, and the return value was this new node 5. Okay, it looked like 5 comma null, and then the current node is node 5, the previous node is node 4, which is this one, and the new node we are creating will have the value equal to 5. What? Oh, you know why that is wrong? Because instead of doing this, I did this. Sorry about that. So this has to be the previous val. And then the previous new node is this one. Does that look good? No. You know why? Because instead of doing 5 to 4, what did I do? I did 4 to 5. So something is seriously wrong here. At this point, go back. See what was missed. Right, so the new node was returned, which is great. Okay, but the new node did not have the reference to the... So that was the head basically that was returned. It should have reference to the next one, which is being created, not the other way around. So this is wrong. So this was the head node, right, which was returned from here. I will rename it once this becomes clear, but for now this was the head node. So the head node was supposed to have the reference of the new node, not the other way around. And the new node would have value equal to null, right? So far we just have these two. So 4 should have value equal to null. And if I send 4, is that good enough? We don't know. Let's again see whether this works. So now what did we change? Head node is what we are going to call this. That will be this one. Current node we didn't change. Previous node we didn't change. New node will be just 4 with null reference basically. I'll call it new node 4. And head dot next, right? This one. Instead of phi and null, it would change to phi and reference to new node 4. Okay. And you're saying we are going to return new node 4. Well, can this be a problem? It surely can be, and we will see how. Okay, let's say now I return new node 4 from here. It looks like this. What will this one, node 3, look at? It is not the stopping condition. Let's forget about that. This one returned this. And the current node is what? Node 4. This is node 3. New node will be having value 3. That is perfect. And reference is null. The head node we say is 4. And the new node will be what? This one. I will call it new node 3, okay? New node 3, which looks like 3. And what are we going to return? This one. Are you seeing the pattern? So basically when we reach here, you will have the reference to new node 1, which is 1, null. So what we are going to return here is not 5, but 1. So this gave us the idea that instead of returning the new node, we need to return the head node. Okay? We need to return the head node. So if that happens, again, here we'll return new node 5. We have made new node 5 reference 4. And then we are again returning new node 5. Okay? But how will it look like? So basically it will look like 5 referencing 4 at this point. And when we come to the node 3, we again have to do some changes. Did you already guess what it is? I think the ChatGPT already told it, but this was a step-by-step way of figuring it out. Let's see. No worries if we didn't figure it out already. There is always a step-by-step approach. So now we come to node 3. I will remove all of this, okay, to make it nice. I will copy this and let's again debug. Not debug, I would say run through the code, run through our exam. So we are inside node 3 now, okay. Stopping condition is not valid. And this has returned the new node 5, this one. This is what we got. Current node is, what is that? Node 4. Previous node is the node 3. The new node is having the value of 3. Okay. But what will this do? This will make 5 reference 3. This is wrong. We want this 4 to reference 3. So basically, we need to, if we are here, we need to go till the end where null is reached. So while we still want to send the head node itself. So we will put list node, temporary node to head node is temp is referencing head. So while temp dot next is not equal to null, that means we have not reached the end. You just say, go to the next one, keep going to the next one. Okay, that is that. Then once we reach temp dot next equal to null, so we have reached 4 in this case, we will say temp dot next equal to new node, and then we are going to send the head node. So what will happen because of this additional logic? We have the new node. I will call it new node 3. It has a null reference. Now temp equal to 5. Okay. Temp dot next will be 4. It won't be null. So we will say now temp equal to 4 here. Now temp dot next is null. So we come to this one. So 4 will be made to reference the new 3. And then we are going to return 5, which is reference to 4, which is reference to 3. This is going in the right direction now, right? So this is the new wonderful logic that we added. Let me add it to where instead of this. So there is a temporary node. And then this is what we are doing. Returning the head. This looks right. Maybe there are some edge cases which is missed, but I think so far it's looking good enough to go and test it out. Oops, I pasted it in the wrong place. So what am I doing? Get reverse linked list is what I'm going to call it. I'm gonna delete all these comments. Maybe I will need it for something, so I'll just keep it for now. So we're gonna say get reverse linked list, put in this head, and we are just going to return this. Okay, will this work? What do you think? And we are not using this one. Okay, this is a different method. Let's make it private first of all, because we want it to be used only inside this class. So let's say run. There was an issue somewhere. Instead of me scrolling like this, I'll see the line number. New node, previous. Well, this was a simple fix, just the name was wrong. Let's try it again. A null pointer exception happened at line number 47. That is possible if a single node is provided or no node is provided. So, not a single node, I'm sorry, no node is provided. You see, that is what was provided, this empty. How did we know there was empty? So, number of nodes can be 0. So, that was one edge case that was missed. So, what happens if it is 0? What do you think? If it is 0, I mean, a node is 0, there are no nodes, we just return an empty one. There's nothing to do. So, if node equal to null, return new y. I mean, I think we don't need to do anything. I will format it. Cancel. That was not formatting. Wow. Okay, so where do we go at? This worked fine. This worked fine. Edge case worked fine. Will 5000 work? It should be fine. This while loop is not a good one, right? We have recursion is already going to traverse through the entire length, which will be length equal to n, then that is 1. Inside it, there is a while loop, which will be 1, 2, 3, 4 till n. So it has somewhere around n square complexity. Just have that word in your head. It is not good. It is slower in time. So, but still for 5000, it should not be a problem. Let's submit it. Let's just submit it. So basically our runtime was very slow. That was expected. So having a while loop inside recursion, that's not a good sign. But at least the good thing is we came to know how to debug. We took a step-by-step approach. We compared with our design, right? We compared with the English statements that we had written, saw what were the errors one by one just by reading the code, right? If you have a debugger, there seems to be a debugger, but well, I don't think it's premium. So yeah, I'm not subscribed. I'm sorry about that. Hopefully we'll do that someday. Not today. But just going through the code, we were able to figure out a lot of things and correct the mistakes, and we got that answer, which was correct. Let's clear it out, right? We can also just ask ChatGPT about the second approach. We don't need to do it ourselves now, just to get an understanding and see how it is different. So let's see. Linked list can be reversed either by reversing the values or by reversing the references. Can you provide a code in Java for both approaches? Yeah. So for values without recursion, so this was with recursion, right? Whatever we did, we could do it here. What is the other approach? Reverse by reference in place. So this is a swapping of the references, if you see here. And here you are. What are you doing? This is what we did in recursion, I believe. So let me ask again. Can you show both approaches again? It's recursion. What? Instead, it's slightly differently. No issues, but I still want to know what did it do here. So the approach that we took, we created a completely new linked list, right? The old linked list is still existing. So we didn't just change the value, nor we changed the reference. We created a new one, basically. So in your computer's memory, the old one still exists. So yeah, that's something to think about, right? And let's see, how is it doing? Oh, wow. It's using JavaScript in one of it. What? Oh, okay, that was the first one. I'm sorry. So let's go back. Let's see, reverse by values. So what does it do? First, the values are collected. Okay. How is it collected? Collect values. Where is that? Where is that method? Oh, that is the method. So as we call this method recursively, you're going to put that value in the array list because you cannot get all the values. Okay. And then assign the values. So again, you're going to recursively go to the linked list, but assign the values in the reverse order. And then you're done. As simple as that. So for reversing by reference, this is what we are going to do. Head.next is head, head.next is null. So what is that? Let me show you. So this is head. Head.next is this one. Head.next is this one. So what you're doing here is you're saying 3 is the head. So basically 3 is referencing the head, okay? I'm sorry, 3 is the head. Where is the eraser? Head and tail. So 3 becomes the new head. Let me go to the right one. Sorry about that. Head.next is equal to null. So 1 is referencing null. 2 is referencing 3. Sorry, 2 is head.next is this one. .next is not 3, so it's referencing this one. Okay, head.next, so 2.next is equal to head, and head.next becomes null. And head.next, nothing has happened to 3 yet, okay? I'm so sorry about that. 3 is still doing its work, it's just sitting there. This is referencing this, and this reference became null. And then we are going to return what? We are going to return this one, which is coming from here, which is this one. So this goes on happening, right? 4 will reference this one. This will become this, and that will get attached to this, and so on. Okay, through recursion. Cool. This was a really long episode, but hopefully you got an idea of how to debug and come across the right solution, though it was not the best solution. And we saw some more elegant solutions from ChatGPT here. So thank you so much for joining me. Hope you had some glimpse of the software world and how you can read through the code and make changes to code written by other people or yourself a long time ago, which you don't remember. So anyway, thank you so much. I hope the reverse linked list problem was also an interesting one. See you next time.